Hello everyone, in this video I will show you how to solve the first half of the exercise Data Topography 2023. So this is the notebook as it was given to you initially and available on OLAT. In the first code cell we basically add all the packages we will need for this exercise. So the first package is plots to make the figures, lazy grids to manipulate some arrays, npz to read the file, statistics. This will be used for the second part of the exercise. The second cell is a function that loads the file. So this we discussed in the lecture. This function takes as an input argument the file name. It will read the file from your current directory, so it's generating a string with the file name here. Reading the file using the function npzRead from the npz library. And then it's extracting data. So DEM here is a dictionary. It has a field X, which we access here using the key X, it's a string here. YC will be another field, H, so X is the X coordinate, YC is the Y coordinate, and H is the topographic map. There is a couple of pre-processing steps here, which just make sure that units are converted to meter and that the reference coordinate is removed. So the map will start from 0 coordinate in the lower left corner. Then in this cell, the function is called. So first we need to activate this one to compile the function. And now we can play this cell. So we load the DEM file. So remember that this file has to be in your current directory. This loads all the data into DEM, and DEM here is a tuple which we read, from which we can extract the fields. So H is extracted by typing DEM.H, XC is extracted by typing DEM.XC, and so on. Here we make a copy of the topography DEM.H because we will need it in the remaining of the exercise. So the first thing is to make a topographic map to display basically the topography. So we want to make a figure. So we will use some tools from the plots library. So let's start with a heat map. So heat map takes the first argument will be the coordinate XC, second YC, and last H transpose, because our arrays are need to be transposed for visualizing them in XY coordinate. So if we do this, we get this figure here, which is a bit rough, so we want to tune it a bit. So the first thing, we need to add labels here. So let's add X label, X, it's in unit meter, Y label, Y unit meters, and a title. Let's run this. So we now have labels on the axis. So everything now is in unit meters, x, y, and h, basically. And you see that the numbers here are large because the effective scale here should be the kilometer. So this is 3 to the power 10 times 10 to the power 4. It's basically 30 kilometers. And here it's also 30 kilometers. So when you have a data set with such huge numbers on the axis, you can simply change. For the visualization, you can convert xc to kilometers. So how to convert something in unit meter to kilometers? You divide by 1e3. Remember to put a dot here because we are dividing the whole array by 1e3. And of course, we need to change the indication on the axis. X and y will now be in kilometers. There we go. We now have x and y in kilometers. So let's continue tuning our figure. First, we want to set the aspect ratio to 1. And let's use the color scheme terrain. Now it starts to look good, but you see that the window is larger than the figure. So we can try to restrict the axis. So to restrict the axis, we can use the option X lim, and we basically want to restrict X lim to XC1 and XC end, and there we are. So we have limited the extent of the figure to the coordinate XC1 and XC end, both scaled to the unit of kilometers. So that's now a nice figure. And we will visualize several times the topography, so we need to, we want to use a function for this. So we will use a function. Let's make a function. So to make a function, you use the keyword function and the keyword end. And we call it visualize topography. We basically want 3 input arguments: the coordinate x, the coordinate y, and the topography itself. So the main thing to do now is to copy what we typed in the previous cell and paste it here. In order to ensure that the figure will be displayed to the screen, we will return the heat map into a variable p and force the display of p. This will make sure that the figure always pops up. So let's compile this code cell. We get a green tick mark. So we have a function. And now we want to make sure that the function actually works. So let's call the function here. We give as input argument xc, yc, and h, which are loaded into the current scope here. They exist into our scope, so we can use them. And let's execute the function. There we go. We repeated the figure. So it looks like our function is working correctly. So now we want to gather some information regarding the data set. So we want to check out the size of the data set. So let's print the size of H. And we now see that the size of H is 403, so 403 pixels in the X, or cells in the X direction, and 344 cells in the Y direction. So we can check now the size of XC. So the size of XC is indeed 403 cells. Then we can check the size of YC, 344. Now we want to extract the corner value of the data set. So we want to use indices to access a specific value. So let's print something here. We want to access H at the southwest position. So the west coordinate will be index 1 and south is 1. So that's 545 meters. It's basically this point here in green, somewhere here. Now to reach the southeast side, we will use end in the X direction. This will give us 272 meters. So indeed, we end up in the blue color here, deep blue color. And now we access the northwest. So west, remember, it's 1 in the first coordinate, but the north is now end. So 483. It's right there in the green colors, 483 somewhere here. And finally, the northeast corner, it's H and end. So you should get now familiar with accessing selected parts of the arrays. So in this question here, I ask you to plot each 5 values in the X direction. So we basically want to reduce the resolution of the image along the X axis, and we want to subsample it. We want to reduce the resolution by a factor 5 in the X direction. So we're going to use our function because we want to plot. So let's copy and paste our function. And we want to apply this reduction of resolution in the X direction only. So we have XC, and we will use a range here. Instead of going from 1 to end, we will introduce a step of 5. So if I just do this, then nothing happens. Basically, it's not working at all because the size of the X array is now being reduced quite drastically. So we also need to reduce the size of the H array in the X direction correspondingly. So we use the same range here. In the Y direction, we don't do anything, we take all. There you go. So you now see the pixels start to appear because we reduce the resolution. This question here asks you to plot each 10 value in both directions. So we want to change the step from 5 to 10. And we also do it in the second dimension. So take care here, be careful, you need to modify the step everywhere. So 1 to 10, 1, 10 to end, 1, 10 to end, and the same for H in both directions. And there you go, you have a nice pixelized map. So in the next code cell, I ask you to repeat the image in the X direction. So we first need to create an array that contains twice the DEM. So we need to concatenate the DEM. I will create a new variable called h2x. And remember, to create an array, we can use the square brackets. And in the square brackets, we can put h, and next to h, separated by a semicolon, we can again put h. So this will concatenate h with h in the x direction. We also need an x-axis, but we need this x-axis to be increasing. Since we doubled the size in x, we need this x-axis not only to reach about 30 kilometers, but to reach about 60 kilometers. So we need to create this xc to x array, which is also a concatenation of the xc array together with the xc array plus xc of end. So this will allow to continue increasing the value of x up to 60 kilometers. Finally, we want to visualize our result. So we can use our function. The array we want to visualize is h to x, and we want to use xc to x as an x array. Let's check. There we go. We now have twice the map, and the coordinates are increasing up to 60 kilometers. Now let's do the same, but in the y dimension. So we want to have the image twice vertically. So we will first create an array, h to y, and this time we will concatenate h with h without semicolon. So this will concatenate h in the vertical direction. So we need an y-axis that now increases also monotonously up to 60 kilometers. So we can generate yc to y. It's yc together with yc plus yc of end. And let's visualize again. This time we use xc. We do not repeat anything in x, but we use yc to y because we repeat in y, and we use h to y, which we just created here. There we go. We have the two images on top of each other. Last step for the first half of this exercise. We now will create a figure which will contain 4 times the map. And for this, let's create one array. We will call it h2 x and y. And for this, again, we use the square bracket. Inside, we will put h next to h. h above x next to h above h. So this will concatenate both vertically and horizontally the h, so the DEM. So we need axes to display, but this axis x and the axis y we already created before. So let's simply use our function and provide xc to x. So that's a correct size array. And yc to y. And this time we visualize h underscore to xy. And there we go. We have generated a map with 4 times the repetition of the digital elevation model. So that's it for the first part of the exercise.